Natalia Vidal, and this is my Choose Your Adventure lab for Physics 2211. I chose to do a Slinky lab, and the purpose of this lab is to track the motion of a Slinky falling straight down, compare it to a model made in glow scripts. The physics principle used here was the force of gravity, which was negative mg, and the normal force, which is mg. Looking at when the Slinky falls, the bottom of the Slinky has tension pulling it up and gravity pulling it down. It has equal and opposite forces acting on the Slinky, so the bottom doesn't move until the tension has changed for the bottom. This explains why we see that the bottom of the Slinky does not move until the top of the Slinky reaches the bottom of the Slinky. The initial position is where the origin is at the top of the Slinky, and the starting position is at the bottom of the Slinky. And since we're starting at rest, the starting velocity is 0, 0, 0. The starting position is also located on the slides. Some error that may have occurred when comparing the graphs is if not enough drag force was applied, especially since the video of the experiment was recorded in slow motion. The system here is the Slinky, and the surrounding is the hand releasing the Slinky and everything else. Before we get into glow script and the results of the experiment, keep in mind that the experiment will be simply by releasing a Slinky from a height and recording the position of the bottom of the Slinky until the Slinky hits the ground. The video is then analyzed in the program tracker to see the velocity as time goes on. Here, the initial conditions are set, and the time is also set from using the program tracker. There is also a big drag because when we recorded, the video used in tracker was in slow motion. Then, the velocity and position update formula is set for the first part of the experiment before the top of the Slinky reaches the bottom of the Slinky. The velocity and the position formulas were derived from Newton's second law. This time interval was retrieved from when the experiment shows that the bottom of the Slinky starts falling. F-net is calculated by adding the force of gravity and the force of tension. The second picture shows that the velocity and position update formula after the bottom of the Slinky starts moving. F-net is calculated by adding the force of gravity and the force of drag. Once F-net was found in both of these pictures, that is what was used in updating the ball's velocity and position. So in the graphs, one can see that they are similar in the aspect that they both start at the same position and stay in the same position until a set time. And then they both drop linearly. As you can see, neither one concave up or down, but instead are linear. Although glow script does drop faster, this may be from an error from not putting enough drag into the line of code. To fix this, one could change the drag. This could have been because of the video being in slow motion. So what does it mean? Why does the bottom of the Slinky stay stationary? Well, as previously discussed, there are equal and opposite forces acting on the Slinky. So the bottom does not move until the tension has changed for the bottom. The bottom knows that there's been a change once the top reaches the bottom and it starts to compress it. And this glow script predicted this correctly. It does because, as you can see, at the beginning it stays stationary and they both around the same point start to move down. Thank you for watching, and I hope this clears up a lot.